Okay. All right. So for this differential equation, we have dx over dt is equal to t over x times e to the t plus 2x. So this is a separable differential equation. So we want to combine all the x's together and all the t's together if we can. Okay, so when we do that, we're going to have, let's see here, I have dx equals, if I multiply both sides by dt, I have dx is equal to t over x e to the t um, plus 2x. But what we can do is we can break that down, right? And so I'm going to do that now. We can break this down into two parts. So I can write this down as x times e to the t times e to the 2x, right? So again, remember this thing here is the same as writing as at e to the t plus 2x. Multiply that by dt. Then what we can do then is we can multiply now both sides by x to get the x to the other side. So we'll have x times dx equals, so again, I'm just multiplying x now on both sides. So then the x here will cancel, have x dx, but I can also multiply by the e to the 2x as well. Okay, so let me do that as well. E to the 2x, e to the 2x. Okay, so we have x e to the 2x dx, and then the e to 2x here will also cancel. And then we'll have t over e to the t times dt. Okay, then the next part is we're going to integrate both sides. All right, so let's do this by parts. So I'll do the left side, part one. All right, so part one here. I'm gonna write kind of small here so I can try to get as much information I can get. So notice here that if we try to use, say, u is equal to 2x, the du will be 2, but we don't, we have an extra x here. So the best way to do this is integration by parts. So we're going to let u is equal to x, and then du is equal to 1x. I'm sorry, 1 dx. There, write that there. So du is equal to 1 dx. And then dv, that's going to be our e to the 2x. So v, um, so we're going to integrate. So we'll let u is equal to 2x. And so du is going to be 2. So 1 half du is going to give me uh, equals to dx. Okay, so then we're going to, so when we integrate this here, we're going to have 1 half e to the u du, but then we'll get 1 half e to the 2x when we replace it back. Okay, so remember integration by parts. It's uv minus the integral of v du. So in this case, we'll have x times that by 1 half e to the 2x minus the integral of 1 half e to the 2x dx. Okay, so it's just these guys multiply together and then these guys multiply together. Okay, so let's see here. All right, so then we can continue on with this and we can continue to integrate this side here, right? So this is basically the same as the one before. We're letting u equal 2x, so we'll have the extra 1/2 again. So what we can do is just multiply this by another half, right? And then we have the e to the u, okay? And then this would be du. So when we integrate that, that will be minus 1/4 e to the u, all right? But then that will just give us 1/4 e to the 2x, okay? All right, so in this case then we're going to have, if I combine this one here, I'll have 1/2 x e to the 2x. Again, sorry, I'm writing small here. And then what we got over here, okay? So that's going to be a minus 1/4 e to the 2x. And then we have our plus c. Okay, so that's part one. So that's what we got for the left side, right? So now let's work on the right side here. Again, I'm just trying to get everything into one slide if I can. Okay. All right, so the right side here, so we're going to work on this now, okay? So we have the integral of t over e to the t dt. So one thing we can do is we can rewrite this as the integral of t e to the negative t dt, and then we're going to use integration by parts again. So in this case, u is going to be our t, so du is going to be 1 dt, and then dv will be e to the negative t. And so our u here will be negative t, and then du will be negative 1 dt. So negative du is equal to dt. Um, so when we integrate that um, here, we'll have will be e to the u, right? So we have the integral of e to the u, all right? Du have that negative. When you integrate e to the u, it'll just be e to the u, so it'll be e to the u, okay? And then we'll just replace that with negative e to the uh, negative t, okay? Okay, so in this case, we'll have negative e to the negative t, okay? Okay. All right, so we'll do the same thing. We'll do the uv minus the integral of v du. So we multiply these guys together. So we'll have a negative t e to the negative t. So again, I multiply this together. Okay. And then there'll be a minus the integral of negative e to the negative t dt. So multiply these guys together. Okay. Trying to keep straight on my negatives here. All right, so these two negatives will give us a positive. So we have a negative t, e to the negative t plus e to the negative t. And then we have another plus c here. Okay, so let's put that all together. So let me write this, give me positive for a second. Okay, so I forgot when you integrate this here, you will have an extra negative. So I know you have the negative and the negative here makes it positive. So when you integrate e to negative t like we did over here, we'll have the extra negatives. So this should be negative t, e to the negative t minus e to the negative t, okay, plus c. Okay. All right. So that's going to be, so that was that side was part two. Okay. So this is part two here. All right. So that's what we got here on that side. So now we're just going to put those two together. So I've rewritten that here. So here's the left side and on the right side. And then when we integrate that on both sides here, we get this information. So now it's just a matter of just, we're just going to solve for C actually. So, first thing here is notice that, as you know, the lab does not like things like with fractions and things. So they want us to multiply this by 4 to get rid of the fraction. So let's just multiply this whole thing by 4. Okay. So that's going to give us 2x e to the 2x minus e to the 2x plus, excuse me, 4c minus 4t e to the negative t minus 4e to the negative t plus 4c. Okay. Okay. Huh. So I'm actually going to backtrack here a little bit. So this c here, I should have brought that over first. Okay. So, but it doesn't matter. Okay. So I should have labeled this C1 and then C2. So this would be 4C1 and then 4C2. But anyway, over here, when we put that together, right? So when we swing this over here, we'll have 4C2 minus 4C1. And then that's just going to be a big C, right? So no matter what we do with that C, it just becomes a big C. And then we're just going to start moving parts together as well. So we'll bring these guys to the left. All right, so let's see here. So I'll bring this one to the left and then bring this one to the left. So we'll have 2x e to the 2x minus e to the 2x plus 4t e to the negative t plus 4e to the negative t. And again, this will just be equal to big C. And then the next thing we can do is we can just factor by e to the 2x. So I'm going to combine these together here and then combine these together here. So I have e to the 2x. And then so I have 2x minus 1. Okay. And then here we can factor out a 4e to the negative t. So 4e to the negative t. So we're left with t plus 1, okay, equals c. All right, and that should be our final answer. Okay, so for this one, we still want to solve this, so we're going to separate these. So when we separate them, we're going to add um, x to the third on both sides here. Anyway, so here we have another differential equations, and we have dx over dt minus x to the third equals x. And what we want to do here is, again, we want to separate them. So the first thing we do is we add x to the third on both sides. So we have dx over dt equals x plus x to the third. And then we're going to multiply both sides by dt. So the dt's here will cancel. Then we have dx equals x plus x to the third times dt. Then we're going to divide both sides by x plus x to the third. Okay, so we have dx over x plus x to the third equals dt. And one thing we can do is we can factor the bottom there. So we have dx, or I'm going to rewrite it as 1 over x times x. Try it again one time. I'm going to rewrite this as x to the third. We take one step at a time. So we have 1 over x to the third plus x times dx. Then I'm going to factor out an x, so that gives me x squared plus 1 dx. And then I just bring this down, equals dt. Okay? So I'm going to solve this in parts. Okay, so we want to focus on, let's focus on this side first. Okay, so that would be our part one. So let me use a different color here. So part one, I'm going to focus on the 1 over x times x squared plus 1 dx. Okay. Okay, so if you remember back in Calc 2, we did a decomposition or a fraction decomposition. So where we focus on this part here, and actually let me write it the right side here. So we're going to focus on the fraction here, 1 over x times x squared plus 1, and then we're going to break that down. So we can, because we need to integrate this, so we're going to break that down to a over x plus bx bx plus c over x squared plus 1. Okay, so what we need to do is we need to solve and find out in regards to this information here, what A, B, and C are. Okay, so we need to multiply everything by the LCD and then find A, B, and C. All right, so again, so in this case, what we need to do is we need to find A, B, and C. So try to delete this. There we go. Okay, so if we multiply everything by the LCD, which is x times x squared plus 1, okay, on both sides. So then on the left side, we'll just have 1. And on the right side, the x's here will cancel. And then we'll multiply by x squared plus 1. And then on the last term there, we'll have bx plus c. And then we'll multiply that by just x. Okay. Again, we're just multiplying each of these terms by the LCD, which is the x times x squared plus 1, and then just canceling the ones that are common between the top and bottom. Okay, so then we're just going to expand this here. So we're going to distribute the a, so we'll have ax squared plus a plus, and then we're going to distribute the x, so we have bx squared plus cx. Okay, and we still have 1 on this side. Then we're going to combine the x's together. So we'll have ax squared plus bx squared, okay? And then we'll have the cx plus the a. All right, and then we're going to factor out the x squared. So we'll have a plus b, and then we have x squared. And this one's will just be the same, right? There's nothing to combine it with. All right, and we still got 1 on the left side. Okay, well, we don't, on the left side of the equation here, we don't have an x squared. So we're going to set the a plus b times x squared to 0. So I have 0 is equal to a plus b times x squared. And then we don't have an x as well on the left side, so we're going to set that also to 0. So that'll be 0 equals cx. But we do have a 1 on the left side, so we'll set that to a. Okay. All right. So we're just going to next is equate the coefficients of each side. So we'll have 0 is equal to a plus b. And then here will be 0 is equal to c. And of course, here it's just going to be a is equal to 1. Okay. All right, so we already know what a is, so we need to plug that a into this equation here. So I have 0 is equal to 1 plus b. Then we subtract 1 on both sides, so we get negative 1 is equal to b. All right, so we got our a, b, and c. I'm going to say that again. We got our a, b, and c numbers. So then we're just going to plug that back in to our what we're working on here on the top part. So let me go to the next page and rewrite this here. So give me a second. Okay, so I rewrote part 1. I'm going to call this now part 2. So I have this one here, the 1 over x times x squared plus 1 dx. I wrote that over here. So this is going to be part 2. And then now I'm ready to integrate. So remember, we can break this down as 1 a over x plus bx plus c over x squared plus 1, okay, and times dx. All right, so we found out from our work that a was 1, so let's rewrite that as 1 over x. B was negative 1, so that's negative 1x. C was 0, so that's plus 0 over x squared plus 1, okay? And then that's going to be times that by dx. Then what we're going to do is we're going to integrate this individually. So integral of 1 over x dx minus the integral of x over x squared plus 1 dx. Okay, so this one's nice. The left side here, this is just going to give us ln of the absolute value of x. This one here on the right, we're going to have to use u substitution. So we have u is equal to x squared plus 1 du is 2x dx, so that's 1 half du is equal to x dx. Okay, so that matches with this. So we can rewrite this as um, the 1 half of the integral of 1 over u du. Okay, so then this becomes 1 half of ln of absolute value of u. All right, and then I can put the u back in. So, so we have 1 half ln of x squared plus 1. Okay, and then I can just bring this down. So that's ln of x minus 1 half ln of x squared plus 1. Again, I can have a plus c here. I'll call it c1. Okay, so that's the left side of the equation. And then now we have dt. Okay, so that's just going to be t, right? The integral of that is t. So let me write that here. Make sure let's go back to this here. So again, I'm working on dt now. So the integral of dt, that's just going to give us t plus c2. Okay, so let's put that together. All right, so let me pause this for a second. Okay, so put the the left side and the right side together so we equal that now. And then we're just going to simplify this. So we're going to use the log rules. So the first thing I'm going to do is going to bring the C1 over to the right. All right, and then I'm going to rewrite this on the left side. I just copied and pasted it. So ln of x minus ln of x squared plus 1. I'm going to raise that to the power 1 half. So remember on the log rules, the coefficient, I can put that as a power or I can put it back as a coefficient. Okay. So I'm just going to raise that as a power and then we'll have t plus, this will be C2 minus C1, which will just be a big C. Okay. All right. Then using the log rules, this is minus, so I can combine them as a division. So we'll have ln of the absolute value of x and then I'm just going to rewrite this as a square root, right? Because 1 half, I can rewrite the square root, so that would just be x squared plus 1 equals uh, t plus c, okay? Okay, so we're going to raise this to both sides to the e, right? So we'll have e and then e. So the ln and e go away, and then we'll have x over the square root of x squared plus 1. And then I can rewrite this as e to the t times e to the c, which again, I can just make that a big C, or I'm going to label it as a, if that's okay. So we have a e to the t, okay? So that's what we're going to have on this side, okay? Now, what I want to do is I want to get rid of the radical. Okay, so again, I'll bring this down here to the t. I want to get rid of the radical here. So I'm going to square both sides. Okay, so I'm going to take this here and then I'm going to square both sides. Okay, so that's going to give us x squared, and then the denominator, the radical goes away, gives us x squared plus 1. Okay, and then we'll have a squared times e, and then e to the t raised to a power. Remember, just when it's being raised, you just multiply those. So that gives us a 2t. Okay, a power to a power, we just multiply them. Okay, and then I'm going to again rewrite this as just a square as another big C, but I'll label it K. That's what they have in the book. So, all right, so it'll be K times e to the 2t. Okay, again, doesn't matter what letter you use. You can rewrite it as C again. That's totally fine. Okay. All right, so just kind of this recap here for a little bit here. So we had the ln of x minus ln of x squared plus 1 raised to the 1/2 equals t plus c. We did all this work and we get to this part. Again, our goal is to solve for x. So I rewrote that on this slide because I'm going to need more space. Okay, so then we're going to multiply both sides by x squared plus 1. So multiply this by x squared plus 1 and multiply this by x squared plus 1. So that cancels. We have x squared is equal to um, k e to the 2t times x squared plus 1. And what we're going to do is we're going to distribute that. Okay, so we're going to have um, k e to the 2t x squared plus k e to the 2t. Okay, so we just distribute that term. Okay, and then we still have x squared on this side. So notice that we have an x squared here and x squared here, so I can move this term and move it to the left. So we'll have x squared minus um, x squared ke to the 2t. I just rewrote that. Okay, so we can factor out an x squared. So that leaves us with 1 minus ke to the 2t. And on the right side, we just bring it down. So we have k times e to the 2t. Okay, uh, almost there. Then we can divide both sides by 1 minus k e to the 2t. Okay, so that cancels, leaves us with x squared equals k e to the 2t over 1 minus k e to the 2t. And then our last step here, because we have a square, we can just take the square root on both sides. Okay, and so we got x is equal, since we have a square root, okay, and we have an x squared, so remember back in college algebra, if you have a power of 2, that means you should have two possible solutions. So we're going to have plus or minus the square root of k e to the 2t over 1 minus k e to the 2t. And that's our final answer.